In this lesson, we're going to look at putting together the transformations that we've done in the past few lessons. 2 lessons ago, we looked at y equals a x squared plus k. Last lesson, we looked at y equals a bracket 8x minus h squared. In other words, the first lesson we looked at k value, the second lesson we looked at the h value, and in both lessons we looked at the a value. Now we're going to put all 3 of them together. This video is going to incorporate 2 short parts. So you can see that it says day 1 here. There's another one that says day 2. I'm going to do both of them in this lesson because they're both very short. Alright, so let's start with day 1. When a parabola is in this form, this is called vertex form of a parabola because we can pull the vertex right out of the equation. The vertex is a point. It's the highest or lowest point. Let's draw a little graph of it just to remind you of what things look like. So if I have a Cartesian plane and if I have a parabola anywhere on the plane, let's just randomly draw a U-shaped graph. That's my parabola. That's the graph of my quadratic. The vertex is that highest or lowest point because this U can open up or down. So this one's opening upward. The vertex would be the lowest point. And again, a vertex is a point, and therefore the point is an ordered pair, which means it's got 2 coordinates, an x and a y coordinate. And the x coordinate of the vertex is going to be the h value that we pull out of this equation, and the y value of the vertex is going to be the k that we pull out of this equation. And that's why when we put it together, we get this. So what this means is that any equation that's in this form, we can immediately know what the vertex is. We can also tell what the direction of the opening is, because if the a value, this one here, is positive, it opens up, and if the a value is negative, it's going to open down. So again, we can tell very quickly what's going on. And then we have the basic step pattern. Remember, the step pattern goes 1, 3, 5, 7, but then the a value will also give us a stretch. So whatever the a value is, we can multiply it times the step pattern. So let's put these things together and just show how it works. Underneath each parabola, we're going to identify the coordinates of the vertex, and we're going to determine whether a is positive or negative. These are both things that we can do really quickly. So the vertex we recognize as is the lowest or highest point. If it opens up, it's the lowest point. So I find the ordered pair. So I go to the x coordinate first. That's at 5, right? So it's 5. And then we go to the y coordinate second. That's at -7. So I can't read it very nicely on the graph, so I'll write it once more here. Vertex equals 5, -7. So you can see it more clearly. This parabola is a U facing up, which means that A is got to be positive. It's as simple as that. If it opened down, A would be negative. Those are the only 2 things you need to look for in this one. For this one, here's the vertex. The x coordinate of the vertex is -3. The y coordinate of the vertex is +10, looking at that scale. All right, so here's -3 from here. Here's +10 from here. +10. That's my vertex. This shape is a U shape opening down, so A is negative. Example 2, identify the coordinates of the vertex, then write the equation in the form y equals a x minus h squared plus k. So this one's asking us to do a bit more. Vertex, still get that fairly easily. So the vertex is the x coordinate, -3, and the y coordinate, +5. Now remember that this x coordinate is also our h value, and this y coordinate is also our k value. So when we go back to this equation, we can plug those in. What we also need to know is the step pattern. Well, we need to know a, and we'll get that from the step pattern. So if we go back and remind ourselves that the basic step pattern goes 1, 3, 5, 7, and so on, in other words, odd numbers, then we can see, does the step pattern of the particular parabola we're looking at follow that, or is it some modification of that? And if it's a modification, we'll ask ourselves, well, what is the modification? And then that will give us the a value. So for this one, well, first of all, I can see that the parabola is opening downward, so I know that a is going to be negative. So I need to know the a value, right? And as far as the step pattern goes, let's go, it doesn't matter if I start at the vertex, it doesn't matter if I go left or right, but if I go, let's go left because I got more room. If I go to the left 1 unit and down 1 unit, I get to another point on the graph. Then if I go to the left 1 unit and down by 3 units, I get to another point. And then if I go left 1 more time and down 1, 2, 3, 4, 5 units, then I get to another point in the graph. So I'm always going side to side by 1 step, and then I'm counting how many steps it takes me to get to another point on the graph. So for this one, it was down 1, down 3, down 5. So that's the step pattern without being stretched, but it's in a downward direction. So all that means is that our a value is negative. So it's not stretched. So that means that a, if it's not stretched, then a is just 1. But if it's downward, it's got to be a negative 1. So when I put these things together, put them into y equals a x minus h squared plus k, and plug in the different numbers, let's color code here. I'll do a with yellow, I'll do h with green, and I will do k with orange. So orange, green, yellow. Okay, let's plug in the different things. So a was negative 1, h was negative 3. I'm going to talk about why I've got a double negative there in a second, and k was positive 5. Again, these are just the numbers that I already identified, and so I'm plugging them in. Now, again, why is there a double negative here? Well, it's because this equation has a negative sign built into it. So this negative sign here, the first negative sign, is just the one that came from the equation. The second negative sign, the one in front of the negative 3, is because it's a negative 3. It's part of the number. It's a negative 3. So they both have to be in there, but then I simplify it. So it's negative 1x, and then those two negatives make a positive, so it becomes a plus 3, and then squared plus 5. This would be the equation. Okay, so those are the steps. Let's do it again. Let's get the vertex. Vertex is right here. Vertex equals x-coordinate, which is positive 1, and y-coordinate negative 10. Remember, the x-coordinate is our h value, which I'll color in green. The y-coordinate is our k value, which I'll color in orange. And then the step pattern, let's see what's happening here. If I go over 1, then how many steps do I have to go up to get to the graph again? Well, hopefully you can see them going up by 2. Then if I go over 1, how many steps do I have to go up to get to the graph again? Well, it looks like 6 if I count them out. And then if I go over 1, in order to get to the graph again way up here, I'm actually going up 10 steps. So our normal step pattern, again, is, so actually let's write down this step pattern is 2, 6, 10, whereas our normal step pattern is 1, 3, 5. So what did I have to do to this one in blue to get the steps that I've got in red, the actual one we have? Well, what I had to do was I had to multiply each step by 2, right? 2 times 1 gives me 2. 2 times 3 gives me 6. 2 times 5 gives me 10. So what we've done is we've taken the normal step pattern and multiplied it by 2. That makes the a value 2. That's how we figure out what the a-value is. Here's a shortcut way of doing it, though, because it's always going to be the case. Since the first step is always 1, right? Since this step here is always 1, whatever the first step in our actual graph is must be how much it's been multiplied by. So since that was a 2, a had to be 2. So I can think about it there, or I can look back at the graph and I can just look at how much is that first step going up. Whatever that first step is going up by, that must have been our a-value. So that's a shorter way of looking at it. So a is 2. Let's put it all together. Again, here is the formula. You know, if we start with this one here, then plug in the different things. A is 2. Minus is built into the equation here. But then h is 1. And k is negative 10. Color these things again just to try and make it a bit easier for you to see where they're coming from. And then if I simplify the signs, y equals 2x minus 1 squared, and then plus minus just becomes minus. There's that equation. Okay, the last one for this first part is draw a parabola. So now we're just going to work backwards. We've got this. And again, let's keep the same color coding. A, I'll color yellow. K, H, I will color green. Remember that minus sign is part of the equation, though. It's not part of the actual H value. And then K is negative 10. There's a plus sign built into the normal equation, so K is negative 10. So 2, positive 3, negative 10. Here's another way that we can describe it. We can say that when we're taking the h value out of an equation, right, in this case h is 3, when I look at the equation, it says x minus 3 in brackets. If I just always change the sign, then I'll have the correct h value. So it says minus 3 in brackets, h has to be positive 3. And so in every case, I'll change the sign when I take it in or out of brackets. A and k values, I keep the signs the same. The vertex is going to be hk. So it's 3 and negative 10. Again, just from these numbers that we had above. Does it open up or down? Well, we decide by whether the a value is positive or not. In this case, the a value is positive. So in other words, it's based on the a, so I'll color that yellow. And since it's positive, then it's going to open up. Is it stretched or compressed? Yes, it's stretched. I can even say how much it's stretched by. It's stretched by 2. How do I know it's stretched by 2? Because a is 2. So I would multiply my step pattern by 2. So what I'll have is a new step pattern that instead of going 1, 3, 5, I'll multiply each step by 2. So 2 times 1 is 2, 2 times 3 is 6, 2 times 5 is 10. If I was going to keep going, then I'd do 2 times 7 is 14, and so on, though I won't have enough space for all that. Let's put it together. Start with the vertex. That's at 3, 10. I know this isn't the world's best graph. It's very small, but if I go over to 3 and then up to 10, then that's up here. Here's my vertex. And this one is supposed to... Oh, sorry, I realize I made a mistake. I don't know if you can see it. Maybe you saw it before. Probably you did. I said that k was negative 10 over here, but then I wrote a positive 10 in here. So I made a mistake, but I caught it. And the reason I caught it is that when I was looking at this, I was thinking, well, I'm not going to be able to sketch this on the graph. And it made me revisit what was going on. So the vertex is actually 3, negative 10. So I go down to negative 10 instead of up to positive 10. And now it's going to fit on the graph when I do my graphing. Because from this vertex, I will now follow the step pattern. I'm going to go upwards. I'm going to go over by 1 and up by 2. So over 1, up 2, there's a point. And I'm going to do that on either side of the vertex. So to the left and to the right. From that point, either one of those points, I'm going to go over 1 and up 6. That takes me up to here on this one, and then again I'll go to the left and do it here. So it's going to be a mirror image. Then I'd go over 1 and up 10, which takes me all the way up to here. So this is a very skinny looking parabola. Okay, but there it is. So that's sketching the parabola. Okay, let's just look at the second part of this, which is day 2, and it's fairly short, I hope. I'll try to get through it quickly anyway. I'm just going to carry on with the exact same idea. Draw the parabola for the given equations below. Okay, so we did each of these things in the last example, so let's just see if we can go through it a bit more quickly, though. Anyway, I'll keep up with my same color scheme. I can see that, I can see that the vertex is going to be -3, -1. Why -3? Because I always change my h value sign when I pull it out of the equation. Direction of opening, up, because the a value is positive. Step pattern, I'm going to multiply the 135 times 0.5. So I'm going to multiply that by 0.5. So 1 divided by 0.5 is 0.5. 3 multiplied by 0.5 is 1.5. 5 multiplied by 0.5 is 2.5. And then if I want to keep going, which I probably will actually have room for, then I'd do 7 times 0.5. In other words, I'm taking half of each of these. And then the next one would be 9, it would be 4.5. That's my step pattern. And that's based, again, on the a value. I'm multiplying the a value by the basic step pattern. So, vertex, graph that first, -3, -1. Here it is. Direction of opening, up. Step pattern is always 1 from side to side, but I'm going to go over 1 and up by only a half this time. Then from there I'll go over 1 and up by 1.5. Then from those 2 points I'll go over 1 and up by 2.5. Then I'll go over 1 and up by 3.5. And if I'm going too fast for you, remember the beauty of these videos is you can always stop and replay what I'm doing or pause to let things sink in. So I know I'm talking faster than I normally do during a lesson if I was doing it live, but I'm assuming that you will pause this wherever necessary. So here is A. All right? For B part, we've got an A value of 2, we've got a H value of +4, and we've got a K value of -6. So our vertex is 4, -6, our direction of opening is up, and our step pattern is 2, 6, 10, and both the direction of opening and the step pattern are based on that a value. First of all, the direction of opening is up because the a value is positive, and then the step pattern is 2, 6, 10 because we're multiplying by an a value of 2. So 4, -6 is down here. So we're going to go up from here, we're going to go 2, 6, 10, so I'll go over 1, up 2. Then from that I'll go over 1, up 6 on either side. Then I'd go over 1, up 10, but I don't have enough room for that, so I'll just estimate it's going to go off the page before it hits that next line, before it even goes over 1 more, so I'll just sort of aim like that. And that's part B. And the last one, A is -1, that's assumed to be a 1 there if there's no number. H is -1 because I changed the sign. K is +8. So the vertex, -1, +8. Direction of opening, down because of a negative a value. The step pattern is going to be -1, -3, -5. It's going to be the basic step pattern, but multiplied by -1 again because that's what our a value is. So -1, 8 is my vertex. We're going to open down from there, and then I'm going to go over 1, down 1. Then from there I'll go over 1, down 3. Now things are getting a little bit messy because I've got multiple graphs on the same page, but I think we can make it work out. Then I'll go over 1, down 5 from both of these points. Then I'll go over 1, down 7. I'll just keep going until I fill up as much room as I can on the grid. If I connect these dots into a smooth curve, it's going to always give me that U shape. Sort of missed with that one, but that's all right. It's close enough. And there's C. So you can graph these really quickly by following these basic steps. Last example, a baseball is hit in the air. Its path can be modeled by this relation here, which is really just vertex form. But instead of using y and x, they use h and d. H for height, d for distance, but it's the same thing. What's the vertex of this relation? Well, it's the exact same as it, as if it was y and x, we'd look at it the exact same way. So this is still our stretch. This is still, when I change the sign, my h value. This is still my k value. So if someone asks me the vertex, it's going to be positive 7 and 25. The coordinates would be 7, 25. What's the maximum height of the ball? Well, remember, the vertex is either the maximum or the minimum. Let's picture what this one looks like. It's going to open down. Well, let's just sketch it, actually. Here's a quick sketch. So I won't put a scale on here. I'll just estimate. So 725, I'm going to estimate, is about here. Okay? And it's going to open down from here. So it's going to go something like this. So this is a baseball. Imagine if you've played baseball, which I imagine you probably have. Ball goes up, ball comes down. Or anytime you've thrown any kind of ball, it goes up and down in this arc shape. So the highest point is the vertex. That's our 725. All right? So what's the highest point? Well, it's the 25. It's the y-coordinate of the vertex, 25 meters. Is this in meters? Yes, it is. So 25 meters. I got that from the k value. What's the height of the ball when it has traveled a distance of 6 meters? Now, this is a bit different. So what they're giving me is a d value that I want to stick into the equation. But I can then just use the equation to work it out. So h equals negative 1.5 d minus 7 squared plus 25. Let's make sure I copied that correctly. Yes. So I'm going to put 6 in for d in this case, and just find out what the h is that goes with it. All right, so following order of operations, I do brackets first. That gives me a negative 1 inside the brackets. And then when I square negative 1, I get positive 1. So I'll do both those steps at once. Positive 1 times negative 1.5 is negative 1.5. Add 25 to that, and I get 23.5 meters. So I can even visualize that on the graph. If the vertex is at 7, and it's got a height of 25 associated with it, then we're finding the height when we're at 6. That's going to be a little bit less. That's where we get the 23.5 from. So it should make sense. What do the coordinates of the vertex represent in this situation? It's the horizontal distance when, how do I want to say it? It's when the ball is at the highest point. Let's put it that way. No, not even when, because it's not time. Yeah, the horizontal distance that is with the highest point of the ball. So horizontal distance, which is 7 meters, that goes with the highest point, which is 25 meters.